Hi PropStats and welcome to 5.2. This is binomial distributions, which I hope you realize is probably 2 since it says bi. So let's get going. Make sure you got your calculator out and let's see how we do. We're going to find the probability of a binomial distribution, calculate the mean and the standard deviation of a binomial distribution. All right, it has to meet 4 requirements in order for us to do this. Number 1, there has to be a fixed number of trials. All right. Is a single observation, so you have to do it a certain number of times. It cannot go on infinitely. They have to be independent of each other, so what happens in one cannot affect the outcome in the other. They all have to be classified into 2 categories. Usually this is considered success and failure. You must be careful here because a success does not always mean something positive. I may be calculating the probability of striking out, where the striking out is what I want to do. Well, that would be considered a success because that is what I'm calculating. So success is what you want. Failure is what you don't want. So success is what you want to calculate. Failure is what you don't want to happen. All right, not necessarily success and failure is good and bad. The probability of success remains the same in all trials. So what that means, this is very important, that the chance of you striking out is always the same. It cannot change. All right, let's keep going. Requirements have to be met or you cannot do this. Okay, notation. S and F are used for success or failure, or what you want and what you don't want. All right, probability of success is P. Probability of failure is always 1 minus P or Q. So P right here is success. Very important. I guess I have it written here. And Q always goes with failure. So when you see this in your formulas, P goes with success, Q goes with failure. Don't forget. N, the number of fixed trials. So how many times are we doing this? X is how many of successes in N trials we want. So N is how many times do we want to get this to be correct? Okay, probability of success in one trial of N trials. So how many times am I going to get this to happen? It is a good outcome, remember, not necessarily true or false. Q is failure in one trial. So how often will this fail in one trial? P of X, probability of getting exactly X successes in N trials. And we will be using StatDist to help us calculate some of this. So make sure you have that ready to go also. All right, Twitter. An adult is randomly selected with replacement. All right, so with replacement means they are independent, which has to be done, otherwise it doesn't meet our thing, right? There's an 85% probability that the person knows what Twitter is. So this is going to be our probability of success. All right? And then suppose we want to find the probability that exactly 3, this will change later on, but right now we're doing exactly 3 of bi. Important to know. Okay. Is this procedure result in binomial distribution? Does it meet all of our requirements? Okay. Identify the N, the X, the P, and the Q. The number of trials. So we need to satisfy our requirements. Do we have a fixed number of trials? We have 5. Yes. Are they independent? We replace them. So yes, they are. Each trial has 2 categories. So they either know or they don't know. So it meets that one. There is a probability of 85%. So that never changes, which means we also have 15% of failure. Check. All 4 are checked. If you do not check your requirements, you cannot do this. It is mandatory that that is done. All right, now let's find out what N, X, P, and Q are. So 5 random adults. That is how many times we are doing this. That is our N in our formula. The probability of exactly 3. So 3 is the X. How many times do I want them to know what Twitter is? Success is P equals 0.85, which means failure is 1 minus 0.85, which is how we come up with a 0.15. And remember, failure is always Q. Now, our formula. All right, I'll show you how it works, but then we'll do it with a calculator. Much easier. It's 5 factorial over 5 minus 3 factorial times 3 factorial. If you recognize this, this is our combination. So how many different ways can I have these people is what this is. I want 3 of the success. So this is success, so this is the probability of success, and I want 3 of them. How many times? 15 is failure, and then how many of them are going to fail? So if I have 3 successes, I have to take my total minus my number of successes to get my number of failure. So total minus how many successes I want equals my number of failures that I want. We are going to use the NCR button. We are not going to use that formula. So we have 5, choose 3. Remember, that's the NCR button on your calculator. You have to do this. Then you take your percentage of successes to the number of times you want them, which is 3. My probability of failure times my number of failures, which is 2. These two numbers have to always add to my total. And that gives us 0.138 when you type that into your calculator. All right. Hopefully you did that right and you practiced. Okay, next we're going to go on stat disk. Let me pause. Okay, now that you got stat disk open, you're going to hit analysis. You're going to go to probability distribution, and we are doing a binomial distribution. Okay, hope you got that. Analysis, probability, binomial. All right, in here, number is how many trials we have, which is 5, because we have 5 people we are choosing from. The probability of success for us is 0.85. Okay, and we're going to leave X value blank because then it will give us all of them. So just hit evaluate. Whoops, I hit 2. And your table shows up. So when we look at this, I want to know the number of 3 successes. So you go over to 3, and the number of having 3 successes is 0.138178, which is exactly what we got. All right. Now, when you look further, X or fewer is 0.164. So 3, 2, 1, or 0 adds it up for you. And 3 or more is 3, 4, or 5 is 0.97. So this is a very nice thing in here, and I hope you did well using that. It helps us out quite a bit. All right, so now that you've gone onto StatDisk, we've done that. And, okay, what is the probability of 3 or more? What Twitter is. All right, so when you looked at your StatDisk, you would have went 3 or more. So we go to 3, not fewer but more, and we have 0.973. So your probability of 3 or more from StatDisk is 0.9, I think it was 73. I hope I remembered that right. And this is from StatDisk. We are not going to calculate that by hand. We are going to use our technology. All right, overtime rule in football. I would like you to write out the formula. You can try to put it into your calculator and see what happens. So pause. Okay, when you type this in, you had 460 total choices because we had 460 games. I had 252 of them is when they won. And there's a 50% chance that you win the toss. So 50% for success and 50% for failure. I want 252 of them to be true and 208 of them to be false. When you type this in, you probably got an overflow error just because our calculators are not big enough to handle this. So I'm hoping after that you went to StatDisk. In here, your number of trials should have been 460. Okay. Your probability is 50%. And you are actually looking at evaluate. Now we want, hopefully, 252. So you went down here to 252. Maybe. Nope. There it is. Nope. Come on. All right, I can't get it to show up on my screen. Well, hopefully you got to 252. And when you type that, and when you look at your stat disk, you should have seen at 252, you would have gotten 0.005. So an exact answer was 0.005. 252 or more games, so that was more than, you should have got a 0.0224. Okay, when we compare, 0.0224 is less than 0.05, which means this is not likely to happen by chance, right? So since this is not likely to happen by chance, if they win the toss, they have a better chance of winning the game. All right, your turn. It's called the devil of the problem. I hope you do well with this. Pause and give it a shot. It should work on your calculator this time. So you had 5 was your total. You wanted to choose 3 of the adults. You have a 60% chance that they know they believe in the devil, and I want to know that 3 of them believe. That means I have a 40% chance that 2 of them do not believe. Type that in. You should get a 0.3456. Is at least 2. So you should have went on stat disk, types it in. So we know that n equals 5. We know we want the third one, and we know the probability of success is 0.6. Type that in, at least 2 or more for this one, and you should have gotten 0.913. I hope you did well. Okay, mean and standard deviation for critical thinking. The mean for a binomial distribution is n times p. How many you have? The variance is np times q, so false and true. Standard deviation is the square root of your variance. Nothing new. Range rule, again, significantly low is below 2 standard deviations. Above is above 2 standard deviations. Let's go. So 460, we're on our NFL football team. So we have 460 is n. How many times are we going to flip? P equals 0.5, so the chance of failure is 0.5. Chance of success is 0.5, failure is 0.5. You're flipping a coin, right? 50-50. So both teams have a 50-50 chance of winning the game in overtime. Find the mean and the standard deviation for the number of wins. So pause and do that. So your mean, you would have taken the 460, how many times, times your chance of success, which was 0.5 for your p-value, and you got 230. All right, in order to find the standard deviation, you have to take the square root of the variance, and the square root of the variance is this 230 that we just found up here, or the mean, times your chance of failure, and you take the square root of that, and you got 10.7. Range rule of thumb. We want to know what separates the number of wins that are significantly low and high. So below 2 standard deviations and above 2 standard deviations. So let's do significantly low first. And that is the mean minus 2 standard deviations, correct? Our mean is 230 minus 2 times our standard deviation, which gives us 208.6. And our significantly high, same thing but addition. You're taking your mean plus 2 standard deviations. So that's your mean, which is 230 plus 2 times the 10.7. And you get 251.4. So our range is 208.6 to 251.14. Should have been in brackets. Sorry about that. All right, is the result of 252 overtime wins and 460, significantly high? The answer is yes, because 252 is greater than 251. So it's above 2. If we wanted to calculate the exact z-score, we would take 252 minus our mean divided by our standard deviation, and our z-score would have been 2.06. So it's 0.06 above 2 standard deviations of the mean. So it's barely significantly high, but it is significantly high. All right, good luck. I hope you do well on your homework.